We've gone through, we've gathered the information, we've analyzed it. We now want to start weeding things out. We think, well, it could be this, it could be an access list, it could be high memory utilization, it could be a Cisco iOS bug. We start to think through very critically, we start to think through the reported symptoms and think through the possibilities that we've come up with and ask ourselves, does this possibility make sense? For example, if this problem happens only occasionally, maybe during a certain hour during the day, it's probably not an access control list that's blocking traffic. I suppose it could be a time-based access list, but in general, it might not be an access control list. We start to eliminate things that just do not make sense, and what we're left with, we might be left with a few possibilities, things that it could be, but we're going to come up with our list of most likely suspects, and we're going to propose a hypothesis. We want to select what we think is most likely. We're going to select the most probable cause. And then we're going to see who's responsible for whatever we're hypothesizing. Is it a router that we need access to? Do we need to escalate this? Is it something that we can do ourselves? And if it's something we can do ourselves, we're going to go ahead and we're going to test the hypothesis, or we're going to get with the person we need to get with, and we can test the hypothesis with them. And when we're testing the hypothesis, we're going to play a balancing act. We need to balance the urgency of getting something fixed right now versus the impact that it's going to have on your end users. True story. When I used to work down at Walt Disney World, I remember one time there was a situation where the key cards, I think they use little wristbands these days, but they had these, they called them Key to the World cards. These little key cards, that was the way that a guest would get into their hotel. They would get into the theme park with these cards. They would buy merchandise. They would buy food. Really important cards. And we got a report, it was about 3 p.m. one afternoon, prime time for check-in at the hotels, by the way, at the Disney resorts. We got a report that a couple of the more expensive resorts, the Yacht and Beach Club, they could not make the key cards because there was a network problem. Well, that was an urgent issue. We got into the company van, we go over to Epcot. A lot of people don't know there's a partial tunnel system under Epcot. We go down under Epcot and we go to the Cisco gear and we start to troubleshoot this catalyst switch. And yeah, we could see that the processor utilization, the LEDs on the front were abnormally high. Something was up. Well, after a few minutes of troubleshooting, we determined what happened. The supervisor engine had failed to run STP, Spanning Tree Protocol, correctly. STP was broken on that supervisor engine. We had redundant connections going in. Now, let's think about this. Let's weigh the urgency and the impact. To truly fix the problem completely, we would need to make a backup of the configuration on that soup engine. We'd need to get back in the van, go back and pick up a spare, bring it back over, shut the switch down, put the new supervisor engine, boot it up, paste the running config back in. That would take a while. That would really negatively impact the customers, the guests that were trying to check in right then. You know what we did instead? You could probably guess. We just took out one of the redundant connections. We broke Spanning Tree. We thought it was better to have a functional yet non-redundant network than to have a non-functional yet redundant network. And then somebody came back around midnight to minimize the impact on the guests, and then they swapped out the supervisor engine. But it's a balancing act. You need to assess the urgency of fixing it right now versus the impact it's going to have on your end users, and also come up with a rollback plan. So if what you do doesn't work, don't compound the issue by doing more stuff. Let's make sure that we can roll back, and then we test the solution. Did what we implement, did it fix the problem? Hopefully it did. If it did, fantastic. We can, our test shows that it's going to fix the problem. We implement the solution, and we're about to document the solution as well. If it doesn't work, no big deal. Let's roll back. Let's go back to square one. Then we might need to gather some additional information and come up with yet a different hypothesis. But hopefully, whatever we did is going to work, and we're going to implement, we're going to incorporate the solution, and we're going to close the ticket. Now, when you close the ticket, here's a lesson that I used to be a network manager at a local university. Here's a lesson that I tried to drill into the heads of the network engineers that worked with me. A problem is not fixed until the user believes it's fixed. You see, they may be doing something a little bit differently than you are. They might be looking at something differently. Just because an issue is resolved to your satisfaction, that does not mean you can close the ticket. You need to get their buy-in. You need to get their approval to close the ticket. And then we want to document whatever it is we did. And Documentation, I realize, isn't really the fun part for many network engineers, but it's a discipline that we've got to master, because documentation is going to help us. It's going to help people we work with, people that come after us, and it can really become an effective tool in our troubleshooting tool belt.